Do we have
Okay.
this page?
No, this is in classroom or it's in front of you. Alright, which show growth and which show decay?
So A is growth.
A is growth.
B is
Why
decay.
is A a growth?
Number greater than 1.
Alright, so this is, you remember what we call this number right here?
The,
B. It's B.
Yeah.
B is greater than 1. Alright, so what about this one?
decay,
Why?
because it's less than 1.
B is less than 1.
Then there's a growth.
It's a
Then
growth.
decay.
Decay.
Then decay.
Wait a minute.
That's growth.
It's growth because it's 1 plus that. So if I'm adding 1 plus anything, it's going to be greater than 1, right?
And that's a decay.
And F is a decay. Okay. Good. Alright, so let's look at number 2. Since January 1980, the population of the city of Brownville has grown according to the mathematical model y equals 720,500 times 1.022 to the x, where x is the number of years since January 1980. Explain what the numbers 720,500 and 1.022 represent in this model. So what's 720,500? What is
That's
that?
the starting number.
All right, that's the starting population when? Like at the beginning of time?
1980.
1980. Okay, because this model is the number of years since January 1980. So in January 1980, the population of, what is this town? Brownville was 720,500. So what's the 1.022?
That's the increase rate.
So it's increasing,
Why like 2.2%?
it's increasing 2.2%
Per year.
per year since 1980. So then our growth factor is 1.022. Remember, percents are for show, but if you want to do something with them, you have to change them to a decimal. All right, so what's the 2000 population using this growth model? What are you going to put for X?
That's 20 because it's 20 years away.
X 20 because it's 20 years away?
Yes.
Okay. Yeah, there's 20 years from 80 to 2000. All right.
Oh. I was thinking of that completely wrong. So you do 72. Sorry, I was just trying to write those down, those examples.
Okay.
As notes.
That's fine. Nothing wrong with that.
It'll be 1, 1, 1, 3, 4.
All right.
Okay. Right.
So just in case people who have to watch this later have forgotten. So what are you putting into your calculator?
720,000 times 500 times 1.022
To the 20th, right? Okay, that's what you put into your calculator because it says X is the number of years since January 1980. We're looking at the year 2000. There's 20 years between 80 and 2000. So we put this in our calculator. And then what do we end up getting?
1113401.75.
I'm just going to get it and read it. Hello.
It's toasty in
Yeah.
here.
It's 1,132,401. And it can't be like,
People. It's people, so we're going to go to the whole number.
yeah, I was gonna say it can't be per person.
All right, so now let's use this model to predict when the population is going to reach 1 million.
So less than 20 years.
Less than 20 years.
Because it's already at well over 1 million.
Yeah, it's over 1 million in the year 2000. So how am I going to set that up?
But you can alpha enter on it and then change the exponent to a lower number.
Would you not
No.
just subtract?
Algebraically, what am I going to do? What am I looking for? What part of this am I missing?
Wow.
The A.
The X, because X is the number of years, and this says when. So I'm looking for years.
Don't you fill that in for Y?
I put this in for Y. 1 million equals 720,500 times 1.022 to the X. Now, how do I solve that?
You multiply that and get whatever that is.
Multiply what?
The 1750 or whatever. However you say that times the 1.0.
No, because this is an exponent, and exponents come before
Okay.
multiplication order of
So,
operations.
There's a little square root thing.
Let's start by getting the variable as much by itself as we can. So let's divide by 720,500. $2,000 over 1441. All right, now if I'm trying to solve for an exponent, what do I use to solve for an exponent?
So just memorizing this. Is that what's going on?
I'm hoping I got
Oh.
What?
Oh, yeah. That's what's up.
How do you solve for a missing exponent? What's the inverse of an exponent?
Sure.
Nope. What's the inverse of exponential function?
Radical.
Nope.
Log.
Log. If it's an exponent that's missing, you change it to a logarithm. Okay? So I have log base what? What's the base?
1.022.
Of 2,000 over 1441 equals x.
Okay, so now we plug into our calculator.
Yeah, you can put that in your calculator.
Oh.
15.06. So when will it reach? After the 15th year, okay? Because it's not year 15, it's after the 15th year, because that's 15.06. When was our first year? 1980, so sometime during 1986. After the 15th year.
After 15th or 16th.
After the 15th or during the 16th. Is that what you mean?
Yeah.
Are you restating your answer, or are you asking me a question?
No, I'll restate my answer.
Oh, okay. Yeah.
Because it's less than 16, so I'm between 15 and 16 years.
After the 15th into the 16th. Okay. All right. Awesome. Okay, try 3A. 3A. You got some beetles. A population of 800 beetles is growing each month at a rate of 5%. Write an equation that expresses the number of beetles at time x. So I'm going to give you a couple minutes to write your equation of how many beetles at time x. I'm going to take roll. We didn't do that yet. All right, what's my original amount of beetles?
800.
800. And what, do I have a growth or a decay here? Growth. So it's going to be greater than 1. How many, what is my growth rate?
1.05.
1.05. Because I'm getting 5% more each year, or wait, each month. So I'm getting 5% more each month. I'm not losing any, so I have 100% of the beetles I had last month, plus 5% more. Is that it? Am I done?
No.
Nope.
Gotta put an X.
Gotta put an X. Where?
As an exponent after
As
the
an
1.05.
exponent. So it has to be, it said write an equation. So I need an equals here. That's an equation. Alright. A is your original amount. Y equals A times B to the X. A is your original amount. B is your growth rate. And then X is your time that's passing. Yes.
How do you get that 1.05?
Well, they told me that it was growing at a rate of 5%.
Yeah.
So if it's growing, so I add it to 1 because I'm going to have 100% of the beetles that I had last month plus 5% more, which would be 105%. Well, you don't actually use percents. You change it to a decimal, so it's 1.05. Yeah. All right, do B. How many beetles are you going to have in 8 months?
For those 182 beetles. Okay.
Huh?
So you want us to round up?
Just round appropriately. I don't want any partial beetles.
Yeah, like so many, and then like a couple legs.
Those are the dead ones.
Just have an antenna.
Somehow these beetles are immortal. So.
All right, so tell me what to write so I know what to put in my calculator.
So 800 with parentheses 1.05 close parentheses to the power of 8.
So in your calculator, you put it in just like this, 800. It looks just like on my calculator, like it looks on my paper. And I have about 1,182 beetles.
I'll put 8.
You put 82. That's a 9 you round up.
Yeah.
Mm-hmm.
I was like, partial beating.
Yeah, it's not a whole beetle. I get it. I get it. All right.
I'm not wrong.
Let's talk about number 4, the half-life of medication.
Wow.
Hi, we did.
Asheville.
We did one like this.
Wow, name brand.
All right. Read through number 4. Can you see all of number 4?
Yeah, there's
All right. Shh. Focus. Okay. Read through number 4. Oh, you know what I think I remember from this is that this is covering up.
Yeah, I was about to say
And I
that.
think I did the same page last year, so I'll have to look on there, but I'm pretty sure that I had to uncover that. I had to move it. Let me just go look. I had this exact same problem last year. I'm looking at last year's page still.
Wow, 2 name brands. Ibuprofen.
Of course, the one time we have name brand, it covers up an equation.
Okay, R equals M times 0.5 to the T over 2.
So one more time.
M times the 0.5 to the T over 2.
All of it over 2?
Just T is over 2. Uh-huh. Yeah. And the M is the initial dosage and T is time in hours. I'll write it down. It's hiding behind that Advil box.
Okay, so 200 would go in for M. On ag? Yeah.
I don't know. Are you asking me or your classmates? Because I shan't tell you.
Anyone who will answer.
Yes.
Okay, so you said
How far do we go on the decimal one again?
3.
You can go 3, that's fine.
I should have said 2.
Well, usually, you can go 3.
and then 5 will go into.
Are you asking me?
No.
Okay, I'm not telling you. It's a secret.
That's 5 hours?
I'm trying to make friends with y'all. Your teacher.
So what do you want?
Or just one? Mackenzie.
What?
Wait,
Mackenzie.
Did I miss something?
Take the time.
How many hours are between 1 p.m. Show you all the stuff that you're going to pay for.
When actually is prom?
You have to sign, like, to give, like, your parents' name and number and so we can try and let them know what's going on, too.
Can I get a guess?
They're in the office.
When actually is prom?
April 13th.
April 13th.
All right, so a 200 milligram dose of Advil is taken at 1. How many milligrams of the medication remain in the body at 6? Okay, so help me set this up. What am I going to put in my calculator?
200
Two.
parentheses 0.5
Uh-huh.
to the power of 5 over 2.
Right, equals what?
35.36. Did we have to do that? Because I just rounded. Yeah, I just started at 35.
Okay. All right. Let's at least go 3 decimal places. At least.
I didn't know if it needed to or not. Because like
Least.
just milligrams.
All right, so now let's look at B.
Instead of a 5 over 2 is a 6.
200 milligram dosage of Advil is taken. How many milligrams of the medication will remain in the body 12 hours later?
And 12 over 2 is 6. So we need to 200 close parentheses, open parentheses, 0.5 to the power of 6.
Because 12 over 2 is 6. All right, what do you get?
1 point,
No, I'm not wrong. Well, I got
3.125, my
Yeah.
bad.
Wait, hold on. What?
That's why I'm just, I think I'm dyslexic sometimes.
Spring break needs to hurry up.
All right, I want you to do 5 and 6. You.
Can we
Do 5
talk
and
to our
6.
partners?
Yep. I'm gonna stop.